Welcome back, children. Children, you know that derivatives and integration together make it to 42 marks in your board examination. So, from board point of view, this chapter is quite important. Although this chapter is quite lengthy, but by remembering few formulae, we can make this chapter very simple and easy. So, before going on to the formulae, let's define the word integration over here. So integration means, in simple words, I can say integration is just the opposite of derivative, or I can say it as antiderivative. Here integration means compilation or combination of all the family of curves. So I will be writing a function which represents all the family of that curve. So here integration now is divided into two main parts, that is indefinite integral and definite integral. For indefinite, that means here we will be introducing a constant c with every function which represent the family of curve. That means indefinite means it is not defined. That's why we write it as c. Definite means it is defined, so we will not be using c, that means a constant, for definite integrals. So whenever I will be writing the formulae, I will introduce a constant, that is c, which will represent the family of curves. So let's first of all try to frame the formulae for indefinite integrals, and yes, I will be telling you how you can remember these formulae by easy trick. So the first formula is integration of x raised to power n dx, which is your x raised to power n plus 1 whole upon n plus 1 plus c. Remember, this represents the family of curve. Secondly, if you want to find out integration of sine x dx, then it is minus cos x plus c. If you want to write the formula for cos x dx, then it will be sine x plus c. If you want to write the formula for integration of sec square x dx, then you will be getting it as 10x plus c. If you want to make it for cosec square x dx, sorry, this is 10x, always write it as x, 10x plus c. If you want to write it for integration of cos square x, then it will be minus cot x plus c. If you want to write it for sec x into 10x, then it will just be sec x plus c. If you want to write it for integration of cosec x into cot x, then it will be minus cot x plus c. Now children, I am stopping here. I will tell you how you can remember these formulae. You know that differentiation of sine x is cos x. So I told you that integration is just opposite of derivative. So if I want to find out the derivative, I will be putting integration on both the sides. So integration and differentiation both are opposite to each other. So these will get cancelled, and here I am getting it as integration of cos x is just sine x. So here what I have written, integration of cos x is just sine x, and plus c to represent family of curve. If say I want to find out differentiation of cos x, then you know differentiation of cos x is minus sine x. So introduce integration sign on both the sides. So here these will get cancelled with each other because these two are opposite to each other. So I am getting it as cos x. Give this minus sign this side, so this is minus x equal to integration of sine x, and introduce one c over here. Now you see, this is integration of sine x. So integration of sine x is minus cos x plus c. Here you are integrating with respect to x. Since you are differentiating it with respect to x, that's why you are introducing that you are integrating it with respect to dx. So if you know the formulae for derivatives, then you can find out the formulae for integration on your own only by just remembering these formulae. So this is how I am framing. These are just opposite to derivative formulae. So let's move on further. Okay, let's move on. Yes children, here I have mistaken, it is cosec now. Cosec x into cot x dx is just cosec x plus c. Okay, now come on to the next formula, which is integration of constant. If you have just a constant, that means 1 into dx, integration of constant will be x plus c. If you want to find out integration of 5, then it will be what? It will be 5x. 5 will go out, so integration of dx, and integration of dx is just x. That's why it is 5x. 1 has come out, so it is 1 into x. If it is something else, the constant is something else, then it will be 5x. For example, I have taken. Okay. Then we have the formula for inverse trigonometric functions. Here, you know that differentiation of sine inverse x is what? 1 upon under root 1 minus x square. So simply I told you, take the integration on both the sides. That means integration of this will give you sine inverse x. So I will be writing it as integration of 1 upon 1 minus x square dx will give you sine inverse x plus c. Then next is, if it is minus 1 upon under root 1 minus x square, then it will give you the formula of cos inverse x plus c. Moving on. Now our next formula is for tan inverse, that is integration of 1 upon 1 plus x square, a square plus x square. It is your tan inverse x plus c. Then we have dx. We are integrating with respect to dx, so everywhere you write it as dx. Next formula, integration of 1 upon x under root x square minus 1 will give you the formula for sec inverse x plus c. And if it is minus dx upon x under root x square minus 1, then this will be the formula for cosec inverse x plus c. Now children, we have one more formula, which is integration of e raised to power x will be just e raised to power x plus c. Then we have formula for integration of a raised to power x dx. This is a different formula from derivative, so just remember it. It is a raised to power x upon log of a plus c. So these are the 5 formulae which you are going to use in the entire chapter. The one more important formula, which is integration of 1 upon x. This is quite important and we use many a times. So this is log of x plus c. Now children, beside these formulae, we have few more formulae which we are going to apply. So these formulae, that means the formulae for integration of 10x. Here देखो, we have not taken integration of 10x anywhere, integration of sec x. So we are going to remember those formulae also with some special type of integral formulae. So let's see what are these. Moving on, we have the formula for integration of 10x dx as log of sec x. So these are the 4 formulae which are in the form of log, and these formula are for 10x, cot x, cosec x and sec x. So you have to remember these 4 formulae which are in the form of log. Okay. Now we have some integrals for some particular functions also, and how you can remember these formulae. Here it is given, whenever you are given in the denominator in your quadratic polynomial form, and if 2 terms are given and if these are 2 perfect terms, and if they are not perfect, then we have to make it perfect. So in the denominator, if you get quadratic polynomial, then you have to apply these formulae. Now I will show you the derivation of the first, and with that derivation you can easily remember these formulae. So let's see how you can derive this formula. This is integration of dx upon x square minus a square. Don't get confused this formula with this formula, because tan inverse x formula we have read in derivatives that derivative of tan inverse x is what? 1 upon 1 plus x square. I have replaced that 1 with a. But here it is plus and here it is minus. Children, they get confused with these 2 formulae, and they actually write these formulae differently. So please make it a point that if it is minus, then you have to apply in this form. If it is plus, then only it will be tan inverse formula. Okay, so let's see the derivation. Here children, this is given to me and this is not a direct formula, so I will try to convert into a direct formula. So how I am going to do the derivation? I can multiply and divide this by 2a. This is 2a upon x square minus a square. Since 2a is common, so I can write this 2a outside, and this 2a can be written as x plus a minus x minus a. Now if you will open the bracket, this x and x will get cancelled, and a plus a will be 2a. So you can replace this 2a with this value, and this x square minus a square can be written as x plus a and x minus a, and you are integrating with respect to dx. So again this can be written as 1 upon 2a integration of x plus a. I will be separating my numerators. So this is x plus a and x minus a minus integration of x minus a whole upon x plus a and x minus a. So here x plus a and x plus a gone. Here x minus a and x minus a gone. You are integrating it with respect to x. So now I am getting it just as dx upon x minus a, which is of the form 1 upon x, and you know integration of 1 by x is log of x. So I'll just be writing it as log of x minus a, and simply here it is again dx upon x form. So again it will be written as log of x plus a. Here now this is log of m minus log of n, which can be written as 1 upon 2a log of x minus a. That means log of m minus log n gives you log m upon log n. So this is the formula which I have written over here. 1 by 2a log x minus a upon x plus a. Now children, if here it is x square minus a square, then this is the formula. If I just reverse the terms with different sign, that means opposite sign, then what you have to do? 1 by 2a you are writing as it is, log as it is, and you are writing it as a plus x and a minus x. Now these two formulae are again same whenever you are having the root sign in the denominator, and when it is x square minus a square or x square plus a square, then it is log x plus whatever it is written over here, you have to write here. Log x plus whatever is written here, you have to write here. Now these formulae you can remember again. It is a one type. This is 1 x square plus 1. That means it is tan inverse. Since I have introduced a, that's why I have written 1 by a, tan inverse x by a plus c. And this is the formula under root 1 minus x square, which is the formula for sine inverse x by a. So do remember these formulae. By small tricks you can frame the tricks on your own also, and if you want to remember it by my tricks, then you can go for that also. So note down these formulae by pausing the video and try to learn them wholeheartedly.